Hello and welcome to this edition of EMS Now Up Close. I am Eric Miskell with EMS Now, and today I get to speak once again with Francisco Almada Lobo. He is the CEO of Critical Manufacturing. Critical Manufacturing, of course, is one of the lead MES systems to the industry. And Francisco, it's been a while since we last spoke. I'm glad to have time to catch up with you again.
Thank you, Eric. It's really a pleasure to be here with you again.
Good. Hey, listen, what I wanted to start off before we get into all the technical stuff, you had your conference again. You do a summit every year in La Porta there. I believe the MES and Industry 4.0 International Summit. How was it this year?
It was great. I mean, we're actually doing it every 1.5 to 2 years. But it was absolutely great because this time we had a little bit more than 600 participants from a little bit from all over the world. And one thing that is happening to this summit is that it's becoming really an ecosystem type of summit. So we had, of course, our customer base, we had our partners, we had analysts, we had startups,
Mm,
professionals from all over the place. So this was a really good mix of people, all trying to bring their heads together and solve the most important problems that our industry is facing. So this is one. Second one, this was really a little bit by intention, is that although MES is the main theme in the Industry 4.0, we started off by, putting everyone on fire with the possibilities of AI. And I think we're going to be able to talk a little bit about that. But essentially, as we, set the stage on fire right on the first talk about the possibilities, was like for 2 consecutive days, people just talked about all the possibilities, all the challenges, all the dangers. So
yeah.
it was truly a theme that resonated with everyone. And so we had at some point things like 3 or 4 parallel tracks, some more technical, some more business related, but all of them, having AI in mind
Mhm.
across everything that was discussed.
Yeah. Oh, that's excellent. Yeah, I know that, and we will be talking about AI. It is such a critical, it's on everybody's mind these days. And it's certainly important when we're talking about MES systems, right? So and by the way, just to be clear too for the audience, and so we're EMS now, we focus on the EMS industry, but your customer base spans more than just that, right? You're certainly covering semiconductor manufacturing, I believe medical device and also industrial, right?
That is correct. So we focus on a few segments, a few verticals, but we go what we call in depth into those verticals.
Okay.
This means we're not a generalist player, but one that has built a system specifically to go in detail into all these 4 verticals and to really create value on those.
Okay, excellent. Yeah, I just want to be clear for the audience so that they know the frame of reference here. Let's start big picture with the MES those two, as far as the importance of MES in the whole digital transformation process. That's been an ongoing process with the industry. I traveled and see a lot of EMS companies, and I see how they continue to struggle and pursue this goal. So speak about that, the importance, how critical MES is to digital transformation.
Okay, great. It's a great question. It's a question that I have to go back to the basics a bit. But MES was born as a layer in between control systems and the enterprise level.
Mhm.
Um, so what we call in this industry the ISA 95 model is between level 2 and level 4. And essentially, this has been created because none of the other layers was able to manage with the necessary level of detail everything that was happening in the production floor, managing products, materials, flows, equipment, and so on. And so for many years, this layer has been entrenched in between the other two and simply bridging the gap. But then as automation systems and machine interfaces started evolving, the MES became, first of all, much more connected to the equipment level, to level 2, and providing data and providing instructions on how the equipment should operate. At the same time, what started to be just the mapping of physical production processes was quickly enlarged its scope into business processes. Think maintenance, quality, logistics, engineering, R&D, to a point that some decided to call it at some point MOM systems, manufacturing operations management to try to distinguish them from the original scope of an MES. But then over the past decade or so, especially with the evolution of IoT, companies started talking about digital transformation. Now, this name is often misused, and we have to distinguish a little bit, at least between the words digitalization and digital transformation. So digitalization refers to using digital technologies to change and improve business processes, while digital transformation is the, how I call it, the strategic integration of these digital technologies across all areas of an organization, leading to changes in the way the operations are done or value is delivered. But details apart, digital transformation is only possible when we do the digitalization of processes. And what was found out was that MES is really at the epicenter of such processes. We call it a digital twin, which is another very often misused term of manufacturing operations. So it was built to map the real processes and with such achieve real-time visibility, achieve detailed traceability and control to ensure that the operations are performed as it should. And this digital twin became the perfect backbone, I don't know how to call it, like a skeleton of additional information, additional sources like the IoT, additional features like, I don't know, augmented reality and some other technologies. And so it became really the backbone of this digital transformation set of processes. It became kind of the first area to go to upon which everything is built. And so to become so, of course, the MES had also to evolve, and we'll for sure talk about that, because it today needs to cope with different patterns from the ones that were available some years ago, which in turn require an evolution of the underlying technologies. But again, what became very clear, and back to your question, is that this backbone became the first go-to type of technology for any manufacturing company aiming to do a digital transformation process.
Yeah, I appreciate the distinctions you draw there, and especially regarding the moms, because I was going to ask you, I hear from a lot of, as I travel and talk to EMS, there, about their software that they have, there seems to be great interest in those manufacturing optimization platforms, which I'm assuming is what the moms essentially is, to use, so are you saying effectively that the MES can serve in that role as well, or is there is a distinction, right?
Yeah, the MOM stands for Operations Management,
Right.
and this was created as a superset of the previous MES functionality. For some time, some companies and some analysts started calling it MOM to distinguish from MES. But then at the end, the industry dictated this is what they mean by MES. Okay, and so today, whenever there's a bidding, there's an RFP, there's anything for a company that wants to select one of such systems, they still call it an MES selection, an MES process, but then they ask lots of questions that go beyond the original scope of MES.
Okay.
So the name evolved, and today is much more than execution systems, but still called MES.
Okay, good.
It's whatever the market decides. That's how I put it.
Yeah, and it can be fickle, right? And then marketing people get involved, and it gets a little, and that's why, because as I understand that the moms, it's use data and AI to discover and resolve manufacturing issues effectively, right? So,
right, it's another way of looking at this. Yes,
yeah.
absolutely.
Okay, good. And let's talk about the AI part, because that is, as you indicated in your initial comments, you set the stage on fire at your conference there with the audience with that. So how is AI, what impact is that having, and how's that changing MES?
Okay, so first I have to talk a little bit about the data part, the data strategies, because MES was born as a transactional system. So what this means is that the MES continuously registers, records, processes, and manages discrete events, the changes. And this is called transactions on the shop floor. I don't know, material movement, a production step, an equipment status update. All of those are discrete events that are recorded as transactions. And so the only thing that MES needed to do was to gather information from ERPs, typically production orders, or from PLMs, or from PLMs, from the product specifications, register all the transactions, and then run reports around it, right? And once again, it lived happily with such approach for some time. But then things started to become a little bit more complicated when the interfacing with equipment became stronger with the automation systems, because this started to make available a lot of data. And the only solution that MES had was to store it within the transactions. Now, when we started to have a much higher cadence of data, with sometimes sub-second level data points, this became no longer a viable solution. And at the same time, companies started to realize that there was a lot of value in this data because they could train machine learning algorithms, AI algorithms. They could start making valuable predictions that could bring significant value to the table, rather productivity, quality, and so on. And so while this data could be stored in separate systems, and many companies started doing that for some time, to take real advantage of this data would have to be enriched with what we call contextual information. It's like the sensor level, data points typically are a measurement and a value. And it would be very interesting to have additional information about, the material, the product that was being run, the machine that was being run, when was maintenance done the last time, and so on. And all this additional context information enrich the original data sets to make it more meaningful and more valuable. And so MES systems have evolved all of a sudden into incorporating different types of technologies that were not only transactional, but that could handle analytics. And this is very important. So, these systems will be able to fetch big amounts of information to train these machine learning algorithms and then predict in real time upon new data points based on this training algorithm. Okay, so this was an evolution that was really important. Some people call these parts blocks a data platform, but this is, in our view, incorporated into this area. So now to AI. So of course, what this started to become was the foundation for the classical machine learning area, the classical machine learning techniques. So this is data science people that run regressions, decision trees, clustering algorithms, and deliver really strong performance on structured data. But then we faced a recent revolution. And back to your point, this was when we started to have people on fire with this, was when we started having generative AI, when we started having large language models, the ChatGPTs. So these were pre-trained models that started to become very powerful. And we just dreamed about how can we bring it MES and manufacturing data context so that it can produce the same type of results that we have when we use ChatGPT now inside production, right? And so the trick here is that these systems have evolved in a way that we now need to provide these pre-trained large language models the specific context of manufacturing information. And there's basically two techniques that are used to doing that. One is called RAG, and I'm sorry for the jargon. It stands for Retrieval Augmented Generation, in which we are encoding documents in a very similar manner to the way LLMs do it as well. And then upon a specific question, a specific prompt, RAG retrieves the relevant information of the documents, a little bit like running a query, and then sending it back to the LLM so that it can do its magic. But there was a second evolution, and this was even more mind-blowing, and was related to AI agents. So everyone's starting to talk about AI agents today. And this was possible based on something called the MCP, the Model Context Protocol. And what's happening here is that we're giving to LLMs the ability to gather data from our databases, to be able to call tools, meaning APIs of the MES itself, to gather data or to actually act. And so what's happening is that we're giving the LLM the position of a brain that all of a sudden can make intelligent data and intelligent decisions and read information from the MES or act upon it. And so this is really a game changer because, all of a sudden we have the entire business logic of our systems, using very rigid deterministic rules. And all of a sudden, they can be automatically updated. We could start having suggestions instead of doing this processes that you have. Why don't you do things in a different way?
Do those require very structured APIs then, Francisco?
I mean, the more structured APIs you have, the more information about those APIs, the more metadata, the more documentation that you have, the better the systems
Okay.
can reason and act upon, right? And so there's a huge amount of techniques to do so, because what everyone is afraid of is that the LLMs can hallucinate, which is a term that became part of our daily jargon today. So
Yeah.
hallucinate means that they are, giving answers, wrong answers, with a strong confidence, like only the LLMs can, right?
Yeah.
And so we don't want that, and so we need to protect against it. But the more information we give to them, the more structured our data, the more rich in terms of information, the better the results.
Okay.
But again, what we're seeing is such a potential that with AI agents, we can go really beyond deterministic logic and use things that the LLMs have, like the ability to plan, the ability to have long-term memory, the ability to reason, to, I don't know, reschedule tasks, adapt to disruptions,
Yeah.
optimize production on the fly. All of this is such a big shift from the rule following to a little bit more what we call goal-driven type of approach. And when we start seeing the first results of the pilots that everyone is doing in this area, these are mind-blowing. It's
Mhm.
unbelievable what these systems can do. But with that comes, of course, also the responsibility and the challenges. And there's a number of them, of course,
Yeah.
in these areas as well.
Yeah, and I want to touch on that because I mean,
Okay.
it sounds like, as you said, the APIs have to be structured. I would imagine that as humans utilizing these tools, the approach should be very structured too. But I'm guessing that the people probably try shortcuts or try to make some mistakes along the way. It's not so straightforward. So, what are really kind of the do's and don'ts, in your opinion, when implementing this?
Yeah, very good. So I mean, I think the first is, and the first is so obvious that sometimes it's even difficult for me to say this. Um, it's so obvious, but so not being followed, which is these technologies should be slowly introduced and with an end in mind. Is what is the value that they are providing? Um, Unfortunately, what we're seeing is that because this type of technology is very accessible today, people rush to put out, the MCP servers and to give all this power into the end users. Again, without considering all the aspects which are important, for instance, security. Just to give you one example, if you don't think these things in terms of security, it's very easy to intersect this information. And many of the MCPs that are in the market are today hackable quite easily. Right?
Mhm.
Um, Nevertheless, just thinking about the do's and don'ts. So, of course, the do's is thinking with an end of mind, is of course thinking about security first and not afterwards. Um, then there's additional things like guardrails. Guardrails are extremely important. So guardrails means that we set the LLMs with policy boundaries that should define, very explicitly what the agents can or cannot do.
Mhm.
And this is what ensures that agents stay within safety, within compliance, within operational limits. Another very important one, and this I cannot emphasize this enough, is what is known as human in the loop, especially when we start putting this out. So the operators of the technology or supervisors, they need to remain involved to review and approve the agent decisions before they are executed. So they
Mhm.
can come up with all these different additional things that can be done, but if we don't keep humans in control and make them still accountable, we'll see in the future explanations like, I have no idea what happened. The agent did it, right? And so this is essential. That cannot happen. And the final one, and this one was already important in classical machine learning, but now it's even more important, is to have what we call decision trails. Decision trails are a form of transparency, which is for every decision, we need to be able to have some information around how was the decision done? What data was used? which logic was followed, which alternatives were assessed. And so this is important so that we can assess at the end if things go wrong, we can improve, and we can register and stay within compliance. And there's recent some tools that can explain what LLMs are doing, what agent decisions went through, but this is a new area, and so the tools are not at the level that they should, and so because of that, we go back to the first ones: think slowly, put guardrails, and put humans in the loop.
Okay. Hey, and what you said there at the end, so is the system naturally gathering that information so that you have that together? Which systems, what languages, what's been considered, all those, is that all naturally being gathered in the process? Or is that another function that has to be?
It's a function that needs to be thought. It needs to be considered. So when you create an AI agent, the AI agent is a kind of a living system.
Mhm.
And this, as a living system, it collects information, it makes decisions, takes decisions. The decisions are approved or not approved by humans, and then the decision has consequences.
Mhm.
And all of this, the agent is constantly evolving its memory and applying its reasoning and improving, like in a virtual circle, improving with every cycle, right?
Mhm.
But again, if you need to think about, okay, for every decision, we want a decision trail. For every decision, we want humans to verify it. The guardrails that need to be put in place, all of these are things that cannot be an afterthought. They need to be thought from the very beginning and put in the system,
Yeah.
like security, which is another one. If these things are not done, then all of a sudden, worst case that can happen is that the results are meaningless. But worst case, there can be serious consequences if these topics are misused.
Mhm. Yeah. You make the excellent point that it is a tool. It's not a panacea for everything that's wrong with your business. And so you keep the managers involved, keep the technicians involved to utilize it effectively.
Yeah, exactly. And that's something which is becoming more common in this area, which is everyone being very scared about these AI tools all of a sudden replacing humans, right? And so this is kind of a common concern across the industry. And what we say to them specifically around this point is that no, AI will not replace humans. AI will replace humans that don't use AI.
Yeah.
Uh, so, it's this combination of the two that makes things so powerful and that can take operations into a different level of efficiency, productivity, optimization. It's this combination of these two. So, it's really important for everyone to understand that because these systems are meant to help and not replace.
Yeah. Yeah. And that brings me to kind of how I wanted to wrap this with you. I heard you state here recently, I did a little research before I did this, and I'm going to quote you here.
Oh God.
The end game of intelligent autonomous operations is worth the effort. But especially in manufacturing and regulated industries, cool tech needs mature architecture and well thought strategies. And that you've been underscoring a lot of that right here. But what struck me there is the end game of intelligent, but yet autonomous operations, right? And that seems to be what people talk about lights out factories and all that. So, how would you assess the industry's development towards this end state and what's still needed?
Well, I think that we'll never get there. It's like an end game, but we never get there. I mean, the only possibility of having a completely autonomous factory is if all the conditions are all the time the same,
Yeah.
which means every time you have the same materials, you have the same processes, you have the same products, you have everything. As long as you have change, and what we know is that every time there's going to be shorter cycles, there's going to be less quantities of each product. There's going to be more personalized items.
Mhm.
Um, Change is going to be constant. And so this constant change is actually what brings, beyond, of course, all the other environmental changes that occur, is what brings this combination of human and technology together so powerful, because there's no more powerful resource, more flexible than a human being. And then if they see side by side with the other part that upon learning the first cycles can continue them, that's really the ideal combination. So I think the full autonomy is utopic by nature, but we're getting into a discussion in which more and more of the standard functions will be automated, and that's for sure. The more advanced ones will always need a combination of these two types of brain working together.
Yeah. Excellent. Excellent. Francisco, you have a gift for explaining these things.
Oh, thank you.
I applaud you for that. You
Not
make
sure about that, but I thank you for that.
well, no, for somebody, I understand this much. And so, when I always appreciate these conversations because I learn. Tell me, for other people who are watching that they want to learn more about critical manufacturing, how should they reach out? Where can they meet and see your company and its representative?
Well, first and foremost, our website. So our website has all this type of information available. Specifically, if you're interested on this, I have released a short white paper that explains all of these concepts of LLMs, MCPs, RAGs, all this jargon that I just did throw on all of you. It's explained in very simple terms in a white paper that has been published. And this will be, a way to see that. Then beyond this, of course, there's a lot of information about the MES angle, the data part angle, the automation angle. All of that is available. There's contact information. I'm also available on LinkedIn, so I typically respond to anyone that reaches out to me. So there's multiple ways of getting in touch with what we're doing. If for, of course, buying our products, that's the best. If not, just for a conversation and for some discussion, it's also quite good to always connect to people.
Yeah. And to attend the next forum or summit that you do.
Yeah, the next summit will be great. Even before that, I think we're gonna be present on Protronic in Munich later this year.
Yeah.
And so this will be also a great opportunity to not only discuss about all of these things, but to actually see the products live and see many of the early applications of LLM technology into MES and data platforms.
Okay. Excellent. Well, thank you for those updates. Thank you for your time and your explanations. This has been excellent. And hopefully we can speak again in the future and get even more updates.
Thank you. It was really a pleasure, Eric.
Good. Take care. Thank you, sir.
Thank you.